So this video is going to introduce our next topic of study, relations and functions, and I think you'll find that a lot of this is review from what you did in Algebra 1 and even in geometry. So let's follow along with the notes, and let's begin with a definition. A relation is a set of points. A relation is a set of points. Go ahead and write down that definition. So if a relation is a set of points, let's just review a couple things about points. You'll remember that points come as ordered pairs, x comma y. X always comes first, y comes second. So if we have the point 3, negative 4, the x value is 3, and of course the y value is negative 4. Now you might also remember that we can graph a point. And a couple things to remember about the coordinate plane. We have the x-axis over here. We have the y-axis going vertically. You might remember that this point right here in the middle, 0, 0, is the origin. And if we wanted to graph 3, negative 4, well, we start on the x-axis and we go over 1, 2, 3, and then we're going to go down on the y-axis, 1, 2, 3, 4. So here is the point 3, negative 4. And of course you'll remember we're not going to have all of those other lines in there. So there is that point. I think you probably remember doing this from your previous classes. So let's go back to a relation. And a relation can be represented 4 different ways. The first, of course, is as a set of ordered pairs, which you already have in your notes. Now the second way of doing this is what we call a mapping diagram, where we're going to map the x's onto the y's. So when we do a mapping diagram, we're going to begin by writing all of the x values, and only write them once, even if they repeat. So for example, we have negative 3, we have 3, and we have 4. Now, the negative 3, and we're going to kind of put those as a whole little set. Now the negative 3, it maps to a 4. So we're going to actually draw a little arrow there. The 3 maps to a negative 1. Draw another little arrow there. Now 4 also maps to negative 1, so we can just draw the arrow up there to that negative 1. But 4 also maps to 3, so we are going to show that. And again, we can make this whole like a little set there. Okay, so that is a mapping diagram just showing how the x's refer to the y's. Now we can also use a T-chart. Sometimes I call it a T-bar because it looks like a little T, or a cross if you want. We have the x values, we have the y values. And here we're going to list everything, even those that repeat. So we have a negative 3, we have a 3, we have a 4, and we have another 4. And of course, negative 3 corresponds with 4. 3 corresponds with negative 1. 4 corresponds with negative 1. And 4 corresponds with 3. Okay, exact same information, just in a different format. And then, of course, we can graph this relation. And we've kind of already done this. So we go negative 3 to the x value, x direction, and then up 4. And that one didn't draw in. My pen's having a little bit of trouble there. So there's the first point. And then we have 3, negative 1 is going to be right there. That's better. 4, negative 1 is right next to it. And then 4, 3 is going to be right there. So my points did not come in very good, but hopefully you can get an idea of what that's going to look like. Okay, so as we move along with our notes, a couple more definitions here. The domain of a relation is the set of x values. So domain refers to the x values. And then the range of a relation is the set of y values. Range deals with y. You might remember domain comes first alphabetically and then range. So domain goes with x and then range with the y's. So if we look at that example up above, we can list the domain and the range. We typically use a capital D. Put a little colon there maybe. And then we're going to use the little squiggle braces, which I am not very good at doing. And we're just going to list the values of the domain. List those x values. -3, 3, and 4. That is how we write the domain. We're going to do the exact same thing for the range down below. Little squiggle brackets. Mine, again, aren't that good. Now, just write the y values. And again, we're not going to repeat anything. Notice we didn't put 2 4s up in the range, or the domain. So our range is just 4, -1, and 3. Okay? Domain refers to the x values, the range to the y values. So let's go ahead and look at an example dealing with all of this. Pause the video and read example 1 to yourself, please. Okay, so we have a problem that's relating months and then temperatures of the Gulf of Mexico down in Florida. So let's begin by writing these as an ordered pair. Now, we don't want to write January, February, March, but maybe we could use numbers to list those. So for example, in the first month, which is January, the temperature is 68. In the second month, February, the temperature is 70. In the third month, March, the temperature is 75. And in that fourth month, the temperature is 78. So there we have the ordered pairs. So I'd like you to pause the video and you're going to fill in the mapping diagram and the T-chart. Let me give you a hint, and the graph. Let me give you a hint on the graph. It's easy here. We can talk about 1, 2, 3, 4, 5. We don't want to count all the way up to 68, but maybe we just kind of start here at 65 and then maybe 70 and then 75. And then we can have 80 and we can put them in there. Okay, pause the video and go ahead and fill these in. Okay, go ahead and check your work. Make sure that yours looks something like mine. Once you've checked your work, go ahead and flip over the paper and let's do example 2. So what are the domain and range of the relation in example 1? So go ahead and list the domain and the range like we did before, pausing the video, and then we'll come back with an answer. Okay, so here are your answers. Double check those. And when you're ready, let's go on to our next definition. So a function, and we're going to be talking a lot about functions, is a relation in which each x gets mapped to exactly one y. A relation in which each x gets mapped to exactly one y. Now this is easier to understand probably by looking at some examples. So let's go down to example 3. Determine whether each relation is a function. So look at example A. Notice -9 maps to -6. There's an x, it's going to 1y. 3 maps to -6. 1x mapping to a y. 5 maps to 21. Now look down here at this 11. It is mapping to both -2 and 8. So this is not a function because you have one x getting mapped to 2 different y values. Look at example B. 3 goes to 15. Good. 5 goes to -2. Good. 6 goes to negative 6, okay? 8 goes to 21. Every x value gets mapped to one and only one y value, so this is a function. Go ahead and take a look at C. Negative 14 goes to 16. Negative 12 also goes to 16. That's okay. 1 goes to negative 2. But 1 also goes to 21. That cannot happen in a function, so no, this is not a function. Okay? This just takes a little bit of practice. Next thing is the vertical line test. You can use the vertical line test to determine whether a relation is a function or not. So the vertical line test, we're going to take a graph and we're going to allow a vertical line to go across the graph. And if that vertical line ever touches the graph in more than one point at the same time, then it is not a function. So let's take a look here. We have this graph, which is a circle, and here's my vertical line. And we're going to move it across this graph. And we're looking, does it ever touch 2 points at the same time? Well, notice, yes, it does. It's touching that point. It's touching that point of the circle. So we say the vertical line test fails. So no, this is not a function. Let's look at example B. Take your vertical line and allow it to go across. How many points is it touching now on the line? Just 1. How many now? Just 1. If we go all the way across, it's only ever going to touch 1 point at a time. So yes, this is a function. Let's look at C. What do you think about this one? Take your vertical line. Can we find anywhere where it's touching 2 points of the graph at the same time? We sure can. So this is not a function. Now, the graphs can get a little bit more complicated. Let's take a look at this graph right here. As we move the vertical line, okay, looks like that's going to be okay. But what about when we get here? Even though the graph isn't connected, notice there are 2 points where that vertical line touches it at the same time. Nope, not a function. Letter E. So we're moving right along here. Okay. And now, what do we think? Well, remember the closed circle says that point does exist. An open circle says that point, the graph is not at that point. So believe it or not, this is only 1 point. So far, so good. So as we move along, oh, same thing, only 1 point, 1 point, 1 point. Oh, only 1 point, only 1 point. So this is, yes, going to be a function. Last one. Take your vertical line, let it go across. Now here it's okay. There's no points it's touching, but that's okay. We continue to move across, and it looks like we're going to be okay. So yes, this is a function. Now I'm going to give you a couple bonus ones just for fun. These are not on your notes. If we move the vertical line over, we're good. But what happens right here? Be careful. These 2 little arcs are overlapping. There are 2 points touching the vertical line. It is not a function. Okay, I promise this is the last one. This dotted line in there is just kind of showing some limits that the graph is never going to cross. We'll talk about those later, but it is not part of the graph. So here only 1 point, 1 point, 1 point, then we jump over, still just 1 point. Remember, this is not, the dotted line is not part of the graph. So this is, yes, it is a function. Okay, so hopefully this whole idea of relation, a function, domain, and range makes a little bit of sense. So we are going to find out. So a little bit of IXL to do, level M, and then notice on the last one we jump to level K. Okay, have fun and God bless.